Hello, welcome to these physics tutorials. I am Effiong Fortune. In this video, we are going to look at physical quantities and units. Physical quantities and units. So, what are physical quantities? Physical quantities are quantities that can be measured. Quantities can be measured. Example are force, time, velocity, etc. And units are used to measure these physical quantities. And these units have a way of being expressed. Look at the table below. Prefix, multiplication factor, and symbol. Now, this means that there are certain units that are derived from other units of a particular physical quantity. This means that for a particular physical quantity like length, let me write it here, there are certain units of length that are derived from another unit of length. So, in one of the units of length is meter, which happen to be the SI unit of length. We have other units like kilometer, or we have other units like decimeter and centimeter. These units are derived from this unit, from meters, by addition of prefixes, right? Addition of prefix, these are the prefixes, and each of these prefixes relates with these units with multiplication factors. So the relationship between pico and meter is 10 raised to the power of negative 12, and this is a symbol. So for nano is 10 raised to the power of negative 9 of a meter. Mica is 10 raised to the power of negative 6 of a meter. The symbols are all here. And deca, 10 raised to the power of 2, that is 100. So if you want to derive deca from meter, you multiply by 100. Don't worry, we'll see that. We'll learn how to do this in our video on unit conversion. So this is centimeter, the famous centimeter. This is the multiplication factor. And down to megabytes, 10 raised to the power of 6. This is a symbol. And terabytes, 10 raised to the power of 12. And the symbol is letter T. Let's look at the types of quantities, types of these physical quantities, because in physics we mostly deal with the physical quantities. And the types of quantities there are two. We can distinguish two types of quantities. Fundamental quantities. Fundamental quantities are also called basic quantities. In this video, I'll be using them interchangeably. Fundamental or basic quantities. Another type of quantity is derived quantities. So let us look at these quantities, each of these quantities. Firstly, basic quantities. Fundamental quantities are the basic quantities upon which other quantities are built, right? So you could say that fundamental quantities are like the building blocks of quantities. They are like the foundation of quantities. Every other types of quantities are derived from the fundamental quantities. Now, the units of these basic or fundamental quantities are called fundamental units. Right? So let's look at this table. This table is a table of some fundamental quantities, their symbol and their SI units. So I just have 6 here. The first assignment is to give me an example of a fundamental quantity, its symbol, and its SI unit in the comment section. So SI unit is derived from a French word. It's derived from a French word which means Systema International. In English, we call it International System. That means that because there are many units of a particular quantity, one unit is usually adopted internationally, such that when you go to America, Nigeria, Spain, they are all comfortable, or they are all very comfortable with the SI units. So the first fundamental quantity here is mass. Symbol is meters. Sorry, this is not symbol rather. Mass, the symbol of mass is M, and the SI unit is kilogram, kg. Don't worry, we'll understand all these SI units in our video on unit conversion. So the second one is length. The symbol of length is L, and it is measured in meter. So time symbol is T, measured in seconds. Note that there are other units of these quantities. So we have angle, we have temperature in Kelvin. Note that there is degrees Celsius and there is degrees Fahrenheit, but this is the SI unit. So we have electric currents. The symbol is I. Symbol is I. It is measured in ampere. The SI unit is the ampere. The SI unit is ampere. Alright, let us look at the derived quantities. So derived quantities are quantities which can be derived, or we could rather say which are derived from the basic quantities. So derived quantities are gotten from the building blocks. The building blocks in this case are the fundamental quantities. The units of derived quantities are called derived units. Units are derived units. So let's look at some examples of derived quantities. I've just listed about 1, 2, 3, 4 of them here. Your second assignment is to give me a derived unit as much as you can remember, the derivation process, the derived unit, and the symbol in the comments section. So the first derived quantity we are looking at is area. Right? So, how is area derived? How is the unit of area derived? It is derived from length. Unit of length in bracket meters times unit of length in bracket meters would give you the derived unit meter squared, written m squared. That means the unit of area is derived from the unit of length. Note that length is a fundamental quantity. So this will give you meter squared. Now this also means that you can actually find for instance, you've been given the length, and you can actually find the area of an object by multiplying the length. Would appreciate that when we solve a problem that answers that question. So the second derived quantity we are looking at is velocity. Velocity is different from speed, although speed is also a derived quantity. I've given you an expo. So velocity is a unit of distance. More specifically, velocity is displacement over time. Sometimes speed and velocity are used interchangeably. Velocity is unit of distance, or the unit of velocity can be gotten by dividing the unit of distance by time. So the unit of velocity is meter per second. The symbol is m per m. This dash, we call it per. This is what we call per second. So the same thing with acceleration. To just look at it. The same thing with momentum. So momentum is unit of mass, a fundamental quantity, times unit of velocity, a derived quantity. One thing I forgot to add is that derived quantities can also be gotten from other derived quantities. So let us take an example of how we can derive the value of a derived quantity if fundamental quantities are given. So let's take this example. If we were to find the velocity of a boy who walked a distance of, let's say, 50 meters, the distance, which is the same thing as length of the boy, which he walked is 50 meters, in 10 seconds. That means the time is 10 seconds. How would you do it? So you have to find the velocity of this boy or run 50 meters for 10 seconds. So you can go back to, a few minutes ago, you would see that velocity is derived by dividing distance or length by time. This is what is in, this is what I said earlier. So distance has been given as 50 meters. Note that distance and length can be used interchangeably. And time has been given as 10 seconds. So velocity is now 50 meters all over 10 seconds, right? So when you divide these, 0 will cancel 0. What you're left with is 5 over 1, which is the same thing as 5. You're left with 5 meters. This is it over second, 5 meters per second. So this is how you find velocity, and this is a way to find derived quantities from fundamental quantities. So a quick recap of what we have done today. We've looked at physical quantities, two types of them, fundamental quantities and derived quantities. And we've known that fundamental quantities are the building blocks. Derived quantities are gotten from fundamental quantities. So we've looked at how we can derive a quantity if its fundamental quantity has been given. So if you've not yet subscribed, please don't forget to do so that you can be notified of our subsequent videos. Thank you for watching.